Hi, welcome to Linear Inequalities number 2. So the first 4 problems that you see on your tutorial notes are ones that I want you to pause the video, do on your own, and after each one, come back and click pause again. All right, so you ready? Go ahead and do number 1 and come back and check your answer. All right, so hopefully this is what you got. If you didn't, pause it and figure out your mistake. We're going to do the same thing with the second one. Go ahead and pause the video and come back to check your answer. Hopefully this is what you got. Note the sign change when we divide both sides by the -7. We went from a greater than or equal to a less than or equal to. Let's do it again with number 3. Go ahead and pause the video. Do it on your notes and then come back and check. Hopefully this is what you got. You could have left the -14/3 as -14/3 or put it in your calculator and approximated it to -4/7. And one last one, go ahead and do number 4 on your paper, pause the video, and come back and check it. All right, hopefully you got the same thing that I did, x is less than or equal to 5. So that was a review of the first lesson that you guys did. And now let's go ahead and look at something new. Technically, this doesn't look like something new, right? We know how to solve 24 is less than or equal to 8x, which sounds weird to say it that way, right? I would actually say this problem, 8x is greater than or equal to 24. But let's go ahead and look at the side that x is on. It's on the right side this time, and so we're gonna get rid of that 8. We want x to be all alone. We're going to divide both sides by 8. 24 divided by 8 is 3. Now, here's where some people get a little tripped up. They see this, if you read from left to right, you read this as a less than or equal to sign. But remember how I told you with inequalities, we always want to read our inequality from the variable first, and the variable is the letter, right? So this inequality I would read as x is greater than or equal to 3. Sure, I could read it as 3 is less than or equal to x, but that doesn't tell me anything about my unknown. In fact, it kind of sounds weird. This way, if I start with x, it says, hey, there's some number x that's greater than or equal to 3. Well, we know there's lots of numbers x that are greater than or equal to 3, but that's why we say it that way. And then over here, we're going to do this problem. It's like 2 inequality problems put together. We're going to divide both sides by 5, so we get x is less than 8. And we're going to put these 2 inequality problems together because of this word and. So we're looking for numbers that are both greater than or equal to 3 and less than 8. So we're going to bring the 8 down, and we're going to bring the 3 down. Now I know we could probably set up so it's exactly 3, 4, 5, 6, 7, 8. Oops, I'm one off. I'm not really concerned about that because soon we're going to be dealing with numbers like 3 and 23, and we're not going to be able to count them off perfectly on our number line. But what's most important is to read this correctly. X is greater than or equal to 3. We're going to put a filled in circle, and greater than means start shading into the right. But let's stop and see what's happening here with 8. X is less than 8, which means we're having open circle for 8, and less than means move to the left. And see where they all come together? So when you see an and, your graph is usually going to look like this, where x is defined as something between 2 numbers. Greater than and less than are both involved. Okay, so go ahead and switch over to your marker board. Oops, you don't have a marker board, do you? So go ahead and pause this video, get a marker board, and come on back. All right, so it's really important for our learning to be solidified in our brain to practice. And so what we're going to do is on your marker board, I want you to write this problem down, pause the video, and come back and check your answer once you have it on the marker board. All right, so here hopefully you have this, and then on the test we are not only going to have to solve, we're actually going to graph. These are called compound inequalities because there's more than one inequality that we're dealing with, right? This is a single inequality, this is a single inequality, but because they're in the same problem with the word and, it's a compound inequality because there's more than one inequality we are working with. All right, so let's go ahead and go back to our note sheet, and this should be the next one that you see. And once again, same thing, it's two inequalities together, but this time with the word or. So this is a compound inequality, but we can work on them singularly because we know how to do that. So with this first one, we're going to add 10 to both sides. And we bring down the 9x, bring down the greater than, 80 plus 10 is 90. And divide both sides by 9, and we get x is greater than 10. I'm going to go ahead and bring down this or to remind me that there's two parts to this problem. And let's go ahead and add 5 to both sides here. Let's bring down the x divided by 3. Negative 4 plus 5 is 1. We don't see this very often, but x is being divided by a number. It's being divided by 3. And we know that the opposite of division is multiplication. So to get rid of the 3, we're going to multiply by the 3. So see how the 3 over 3, that goes away? Whatever we do to one side, we do to the other. We don't get a lot of practice with that, do we? So we have two things going on. We have this unknown number x that is either greater than 10 or less than 3. And this is where we have to be really mindful, because see how we have to ask ourselves before we do our graph, who's smaller, 3 or 10? Obviously 3 is. So we want 3 to be written first and 10 to be written further down this way, right? Sometimes if people are not thinking, they just bring the 3 down and the 10 down and get the whole thing wrong. All right, so let's see. Let's look at the 3 first. X is less than 3. That means that we have an open circle, and less than means to the left. Let's look at x is greater than 10. That's an open circle, and greater than means to the right. It would make sense for an or to look like this, wouldn't it? That x is either less than something or greater than something. So the shading is going to be going both to the left and to the right. X can't be both greater than 10 and less than 3, right? That's not possible. That's why we have to use an or. And ors look different than ands when we graph them. So let's go ahead and switch to our marker board again. And I want you to write this down on your marker board and solve it. Pause the video first before you solve it, and then unpause it and check your answer. All right, so hopefully you got this. This is a good time, if you're not getting this, to pause the video and flag me over if you are in my self-pacing class. If you're doing this at home, just kind of put a star by this type of problem, and you can come in and ask me when you get back in class. All right, so let's switch back to the notes. We're on the back side of the notes, and this looks a little different. This is also a compound inequality. It's actually an and problem, but it looks a little different. We have a choice here. We could go ahead and rewrite this as an and problem. We could rewrite it as 18 is less than negative 2x minus 4 and negative 2x minus 4 is less or equal to 38. We could do that and then solve both of them, but I don't recommend you doing that. But I just want you to know this is another way that an and problem can present itself. It is an and problem. So here we go. Here's what we're going to do. Imagine if this part right here we didn't see, and it was just a single inequality. What would be the first thing that we would do to solve for x? That's right. We would add 4. We would add 4 to this side and add 4 to this side. Well, guess what? This really does exist, and guess what we're going to do to that left side? You got it. We're going to add 4. So it feels a little weird first. We're used to doing the same thing to both sides, but when we have a compound inequality like this where x is stuck in the middle, and it's another type of and compound inequality, we're going to do the same thing to the middle as we do to the left and the right. So here we go. 18 plus 4 is 22. And then the negative 4 and the 4 cancel out. 38 plus 4 is 42, right? And then we're going to divide both. We're going to divide the middle by negative 2 to get rid of it, and both sides by negative 2. Oh my goodness. You know what we did? We divided by a negative. So real quickly, let's go ahead and switch our signs. We realize that x is alone in the middle. 22 divided by negative 2 is negative 11. 42 divided by negative 2 is negative 21. All right, so let's stop here for a second. I think the math was pretty straightforward once we got used to the fact that Not only were we doing something to both sides, we were doing them to 3 parts, right? The middle and the right and left part. And once we got used to that, we're just basically doing what we always have been doing when we're solving. But let's stop here, and we need to ask ourselves, whenever we're doing a compound inequality, before we do our number line graph, we need to ask ourselves, who's smaller, negative 11 or negative 21? And you're right, negative 21 is smaller. We need to make sure that we put it over here. I hear you, 21 is bigger than 11, but as far as negatives go, think about the number line. Negative 21 is way further away from 0 than negative 11. Negative 11 is bigger than negative 21. We don't care that the spacing is right. We just care that we put the negative 21 to the left. All right, so x is stuck in the middle. So we're going to read from the middle. We always are going to read our inequalities using x first. So x is 2 things. It is less than or equal to negative 11. All right, let's start there. It's less than or equal to negative 11. Let's go to the negative 11. We see the equal to sign, so we're going to fill that in. It's also less than, so let's start. And we're going to stop here for a second because we want to see what else is going on with this problem. X is also greater than or equal to negative 21. So we're going to go to the negative 21. We'll put a filled in circle. Greater than means this way. And just like all ands, our shading ends up meeting in the middle. So this graph, this number line graph, describes what our answer to an inequality was. All right, we need to practice that for sure. So let's go ahead and switch to your marker board, write this problem down, and pause, come back, and check your answer. All right, hopefully you got that right. And if you didn't, see if you can catch your mistake by looking at my work. Let's try another one on the marker board. So let's do this one on the marker board as well. The one that you just did didn't have a negative number in front of the x, and we need to practice when that happens. So write this down on your marker board and hit pause and come back and check your answer. All right, so once again, first of all, we got not a pretty number, and that's okay. We could have used the negative 32 over 3 and written that down, or you can go ahead and approximate it as a decimal, right? The negative 10.7, because it was really negative 10.6666666 repeating, right? So we ask ourselves, who's smaller? Negative 10.7 is smaller than negative 4. And if you don't believe me, just think about any number line, okay? And it's really easy when numbers are positive to see who's bigger and who's smaller. But think about when they're negative. See how negative numbers work? Negative 10.7 is definitely less than negative 4. All right. So now we are going to I believe this is number 8 on your notes, so let's go ahead and do this together. It is a compound inequality that involves an OR. So we're going to work this as a single inequality, as 2 different single inequalities. So we're going to go ahead and subtract 2 from both sides, because our goal is always to get x alone, right? We're going to divide both sides by negative 5, and we're dividing by negative. Let's switch that inequality sign. I'm going to bring down the OR. And then let's go ahead and do this one. We're going to add 12 to both sides. Bring down the negative 3x. 12 minus 3 is 9. We're going to divide both sides by negative 3. Oh, negative or dividing both sides. I can sometimes put myself in a trance doing math. It's very calming, and then I won't remember things like, oh no, I just divided both sides by negative. But I did. I caught myself. Hopefully you caught yourself too. 9 divided by negative 3 is negative 3. And now, once again, we ask ourselves, before we make our number line graph, we ask ourselves, who is smaller? Negative 3 is definitely smaller than 2, so we'll put negative 3 here. We'll put 2 here. And let's see what it says for x and negative 3. X is less than or equal to negative 3. That means I'm going to do a filled-in circle and move to the left. X is greater than or equal to 2. Means I'm going to do a filled-in circle to 2 and move to the right. And once again, most ORs that you see will look like this, the shading going both to the left and to the right. All right, let's see if I have a marker board one for you. Oh, I don't. Whew, you got spared a marker board problem. All right, so we're moving into some word problems that represent inequality. So let's read this together. According to our mom, Mirabelle has to be at least 13 in order to get her cartilage pierced. It just sounds so painful to get. So maybe think about that twice before you decide to do that. So here we go. She has to be at least 13. So let's just do a number line actually. Let's write 13. And then let's remind ourselves that there's 14, 15, 16 as we move to the right. And as we move to the left from 13, there's 12, 11, 10, and 9. So we look at the number line, we think, can Maribel get her cartilage pierced when she's 12? Nope. How about when she's 12 and a half? Nope. How about when she's 12 and 364 days? Nope. Can she get it pierced when she's 13? Yes. So sometimes it's easier to do the number line before we actually do the writing. So 13 is part of our solution. Can she get her cartilage pierced when she's 13 years old in 1 day and 2 days and 13 and a half, and when she's 14, when she's 15? Absolutely. She can get her cartilage pierced. Once again, this is going to be one of those where technically we should have an ending point because Maribel's not going to live forever unless she's a robot that can keep getting fixed. Anyway, so for me, it's easier to do the number line first and then to say we're going to let X stand for Maribel, and we know that 13 is an important part of her inequality, and we know that Maribel, her age has to be at least 13, so that means she has to be greater than or equal to 13. So whichever way you want to do it, the test is going to ask us to do both. So maybe you're like me and just doing the number line first will help you. All right, let's look at another one that's on our notes. The slowest that Evelyn runs is 12 minutes a mile, while the fastest pace she can run is 6 minutes a mile. So I'm going to do my number line first. I'm going to put a 6, and then I'm actually going to try to space this out. Let's see if I can do this. 6, 7, 8, 9, 10, 11, 12. Evelyn kind of sounds like a robot, to tell you the truth. I know that if I'm not feeling well, I'm going to run way slower than a 12-minute mile. Well, when I'm just feeling normal, I'm going to run way slower than a 12-minute mile. But most of us, right, don't have a set parameter for our running. But Evelyn, robot Evelyn does. So let's see. The slowest she runs is a 12-minute mile. Can she run a 13-minute mile? Because I know, and now this is weird, 13 is bigger than 12, but 13 is slower than 12, right? If you take 20 minutes to run your mile, that's way slower than 12 minutes. So 12 minutes is the slowest she can run it. Can she run exactly 12 minutes? Yes, so we're going to fill that in. All right, now let's go look at the 6. The fastest pace she can run is 6 minutes a mile. Can she run a 5-minute mile? No, she cannot. Can she run a 5.5-minute mile? Nope. But you better believe she can run exactly a 6-minute mile. She's definitely a robot. Okay, can she run all these times in between? Can she run a 7-minute mile, a 7.5-minute mile, an 8-minute mile, and an 8.5 minutes? Absolutely. So what we have is Evelyn's running pace, which we're going to let X stand for that, is stuck between two numbers, 6 and 12. And when I look at it this way, I can tell that X has to be less than or equal to 12 and greater than or equal to 6. So once again, that might be the easiest way to go about it. If you can do it the opposite way, more power to you. All right, Laramore's favorite temperatures are when it's either over 95 degrees or under 32 degrees. I think Laramore is also a robot. Okay, there's something not quite human about this. So I see an or, which is good because that means that I'm going to have an or in my inequality statement, right? My compound inequality. So I'm going to go ahead and do the number line first and then write it. I see two numbers. I see 32 and I see 95. I'm not going to try to space this out because I don't have the space. All right, so he likes it when it's over 95. Okay, does he like it when it's exactly 95? Nope. So we have to have an open circle here, and he likes it when it's over 95, which makes it easy to know we are shading to the right. All right, let's look at 32. He likes it when it's under 32 degrees. Does he like it exactly when it's 32 degrees? I think not. So that is an open circle, and under 32 is shading this way. All right, how do we write it? We're going to let X stand for Laramore's favorite temperature, and we're going to put a 32. We know Laramore likes it when it's less than 32. We're going to let X stand for Larimer's favorite temperature, and the 95 is on the other side. And we know that he likes it when it's greater than 95. All right, I think we have one more. I was trying to make the 20-minute mark. I think with all the practicing on the marker boards, it's making it a longer video, but I really think the practicing on the marker board is really important. All right, so here we go. X is going to be stuck, right? X is stuck between two numbers, a 3 and a -4. And so what we're going to do here is put X is going to be what? Less than 3. So if I read it this way, X is less than 3, that's what it says. If I read it going this way, X has to be greater than -4. So as X is stuck in the middle, X is less than 3, but X is also greater than -4. And I think that's it. All right. Thanks for joining me. Let's double check that I don't have anything else. I do not. Thanks for joining me.